Factor trinomials we must. Leading coefficient is bigger than 1. All right, excuse me for the weak Yoda imitation. I'm in kind of a goofy mood. So we're looking at a trinomial with a leading coefficient or digit right there that's bigger than 1. So definitely tougher than your standard trinomial factoring problems, but doable. So first thing we always want to check for when we're doing any kind of factoring problem is for greatest common factor. So is there a number that goes into 8, 47, and 6 besides 1? And the answer to that would be a big fat no. Do they all have x's? Do they have an x in common? Also a big fat no. So moving along to the only other possibility, which would be a pair of binomials. So I've heard them all. I've heard the umbrella method, the down-under method, the box method, et cetera, et cetera. Any way you look at it for all those methods, and they're all pretty cool. They're all really well thought out, smart. You still have to remember a procedure. So to me, good old-fashioned trial and error is the best way to go. So basically, here's what we're going to say. I need something times something that's going to give me 8. And that's what factoring means. So let me list those guys out. 1 times 8 is most definitely 8. 2 times 4 is most definitely 8. So to me, a couple shortcuts here. So here I'm going to concentrate on this 47 in the middle. Well, the only way I'm going to get this problem to end up equaling a pretty big number like 47 is if I use a big combination of numbers. So most likely, my answer is going to have a 1x and an 8x. Now, not always, but usually that works out. So what else do we have to consider? Well, we got this negative 6 on the end. So I need something times something that's going to give me negative 6. Well, let's see. 1 times 6 definitely equals 6. Worry about the sign here later. So the kicker with these guys is that if you flip them around, it makes a difference. So it could be 6 and 1. Also, to get a 6, it could be 2 times 3. Flip them around 3 times 2. Now, here's a little detail that most people don't realize. Let me just, for the sake of argument, say the answer is 1 and 6. There was a reason that I asked you if there was a GCF in the original problem. Because if there's a GCF in the original problem, there cannot be a GCF when you do the factoring. So if you take a look at these two guys, there's a number that goes into both. In other words, they have a greatest common factor, and that can't work. So I know right now 1 and 6 cannot be a possibility. So let's get rid of those guys. Can't be 1, can't be 6. So look at the possibilities that we've written down. If I were to put the 2 in with the 8, there's also a greatest common factor. 2 goes into both of those. So that guy's not going to work. And like anything else, you do it enough times, you start to realize that pretty darn quickly, and you don't have to worry about it. Well, it's either a 6 and a 1 or a 2 and a 3. So just for the sake of argument, let's say that the answer is 2 and 3. Trial and error, I'm guessing. Well, I want a negative 6. If I want a negative 6, the sign is going to have to be 1 negative and 1 positive. Now, if you get this far, basically all you got to do is check to see if you're right. So we're looking at a FOIL problem if we were to multiply it back out. Now, I don't really need to check this guy times this guy. That's the reason we picked 8x, 1x and 8x in the first place, to get the 8x squared. I don't really need to check 2 times 3. So F for FOIL, the F and the L. Don't need to check it. That's why we picked it. Don't need to check it. That's why we picked it. So let's check the O and the I. So if I were to multiply the outside ones together, I got a 3x. If I multiply the inside ones together, I get a negative 16x. I combine those, I get a negative 13x. Well, I hate to break it to you, but we do not have a negative 13x in the problem. So that was kind of all for naught. But trial and error is trial and error. So let's get rid of all this. But again, like anything else, you get good at it, you don't have to worry so much. Well, it's not 2 and 3, so what's left? Going to have to be, forgot to get these guys out of here. It's going to have to be 6 and 1. So the only question is, do we have the signs right? Again, I don't need to check the first from FOIL because that's why we picked x and 8x. I don't need to check the last. All I need to do is multiply those two guys, multiply those two guys, and see what they end up being. Negative 47x. Well, pretty darn close. The only thing we got wrong is the sign, but that is easily fixed. So if I were to come back up here, make that guy a positive instead, make this guy a negative instead, then that's going to change these. And voila, I've got myself a 47x, and that guy checked out. So trial and error. Give it a try. Thanks for watching the video.